afternoon, class. How many of you enjoyed swimming in the ocean a couple weeks ago? All right. Good show of hands. What's the difference between the ocean and the type of water that you're used to swimming in at home? When it comes to your rivers and ponds, what's the difference?
The seawater is more dense than the usual freshwater or river water that I'm used to.
Why would you say it is dense, Edwin?
The seawater is more, you have to use more effort to swim in, and because of the salt, it makes the water more dense.
Okay, all right. So clearly then there is a difference between the river water that you're used to, the ponds and streams, as opposed to the seawater, which is more salty, right? Today's topic that we're going to discuss is called saltwater intrusion into aquifers. Have you heard any of those terms before? Aquifers, you've heard aquifers. Erwin, can you share what you know about aquifers? You just heard the word? Okay. So hopefully today, yes, Edwin?
Aquifers are underground water sources. Those are the same sources of water that you need to dig for in order to get a well or something. Well, I know it's an underwater source.
Okay, it's an underwater source, which is very good. Before we move on, we're just going to look at some of the terminologies that we will need to know for the rest of this lesson. And like you just said, one of the first terms is aquifer, and it's a geologic formation that is porous enough to transmit water at a sufficient rate to feed a spring or a well. How many people have seen a well before? Describe your experience with a well. Edwin, what do you know about a well? Edwin?
I've actually seen when they dig up all the dirt from a well, when you're looking for a place to do a well. When they take out all the dirt, you notice that the water that pours in isn't very clean, so you have to take out all the dirty water. After a while, the water continues to rise. It doesn't stay at one level. It continues to rise, and it gets more clear, and eventually it will stop. It won't overflow. It will stop, and then the water will be clean enough.
Okay, all right. But what's the science behind that? Why would we dig a well? Why dig something in the ground, and where does the water come from? Stephen?
People dig a well for fresh water, and the water comes from an underground spring.
Okay, people dig a well for fresh water. So you notice then that they would dig a well that is deep enough, right? And then something happens after digging through some feet of soil. Eventually water comes up, but they have met something in particular that you've been introduced to before. Where does the water come from that comes up from that well? They say that whenever water comes up from a well, it means that you have hit the Erwin?
Underground stream or river.
The underground stream or river, yes, almost, but there's a specific name for that, Edwin?
Water table.
You have hit the
water table.
Water table, right? And where did we talk about the water table? In reference to what?
Water cycle.
The water cycle. Thank you very much, Erwin. So we discussed the water table when we spoke about the water cycle. And we're going to review that in a minute. Groundwater is water that exists in aquifers underground. So it's just the water that exists underground. And then we have a term called salinity. And salinity is the saltiness or dissolved salt content of a body of water. Would you say fresh water has a high or low salinity rate? Low. Would you say the water from the sea has a high or low salinity rate?
High.
How would you know that the seawater has a high salinity rate? Yes, Ainsworth.
The seawater, you could tell because one of the taste and it looks different than fresh water.
Okay, so you can literally taste the salt, right? Sometimes when you go and you bathe in the seawater, your eyes and all of that would burn you because of the high level of salt in there. So we can just recall these three terms because we'll be using them several times as we go through a lesson. Aquifers, groundwater, and salinity. Now let's have a look at the water cycle. The water cycle, also called the hydraulic cycle. Which volunteer would like to explain this process for me? You've met this diagram about 3-4 times already. Erwin?
Well, first the water it collects like in the sea or river, then it evaporates, it goes up, it condenses, turns into clouds, it goes to precipitation, the clouds get heavy, the water pour down, then after that it runs off the surface of the earth into the rivers and seas all over again.
Okay. What happens during condensation and transpiration?
Transpiration is when the water is sucked directly from the plants, goes into the clouds and precipitates again.
Okay, and condensation?
When the water turns into clouds, from the after it evaporates.
From what in particular? Remember you told me that
Plants.
transpiration occurs when the water evaporates from
Plants directly from the plants.
But condensation occurs when the water evaporates from what?
Condensation occurs when the water droplets or water vapor cools off and they gather up together to form clouds.
But where does that come from?
The water droplets from the evaporated water from the transpiration process.
Okay, listen to me, right? We have two processes that take up the vapors into the air. We have transpiration and condensation, right? We said that transpiration occurs from the plants. So where does condensation occurs? Yes?
Bodies.
Directly from the water bodies. So when we have that process evaporation taking place from the water bodies, and then we have condensation taking place. We have transpiration taking place from the plants and then up to condensation taking place. Now, in this photograph, where would the water table be located? Beneath the surface? Why not on the surface? Why wouldn't the water table be found on the surface? Edwin?
The water table would be found below the surface and not on the surface because the water on the surface is called runoff. The water that is infiltrated into the ground then hits the saturated zone, and then it goes down lower into the water table, where all the water is being.
Now, Edwin mentioned the process infiltration. The minute infiltration occurs and water is soaked into the ground or soil, then that water is then called groundwater. Any water above the surface is called surface water. Any water that is infiltrated through the soil is called groundwater. So remember, we just did that term, right? So we will keep in mind what groundwater is as we continue. Now, in your groups, I have 3 questions that I'd like you to discuss quickly. Where does drinking water come from? Where do farmers get water to grow their crops? And how is groundwater different from surface water? So in your groups at your tables, kindly discuss the responses to those 3 questions. You just need to write it on a sheet of paper. Don't use the newsprint as yet. Okay, class, let's look at our 3 questions then. And the first one is, where does drinking water come from? Yes, Erwin.
Well, most drinking waters that the factories get to clean, to filter, they usually come from rivers or streams because they're fresh water and they're easier to filter than the seawater because the seawater is salty.
It's salty. Okay, so you say that it comes from rivers and streams. Okay, anybody else has any other answer to add to that? Where does drinking water come from? Where does the water from the well come from?
Underground.
Yes, Stephen.
Underground.
It comes
Underground.
underground, which is called groundwater, but particular from which type of groundwater? The well gets water when it has hit the water. Yes, Irma? The water table. So we can also get drinking water from the water table as well as rivers and streams, etc. Where do farmers get water to grow their crops? What are some sources of water that farmers use? Yes, Yadira, where does water come from?
Usually they make wells and get it from underground.
Okay, they make wells and they get it from underground. But how do they give water to the crops?
Pumps.
They make pumps. Okay. Anybody else wants to expound on that? How do the farmers water their crops? Yes, Edwin.
I think the Jadira is right. They use pumps, or maybe they use some sort of equipment that use gravity or something, like a tank that is elevated and gravity carries it down via some pipelines or hoses with some holes or something.
Okay, I think what you're talking about is called a drip irrigation system, where they punch holes into pipes and then feed water into those, some sort of like a sprinkler. You've seen a sprinkler system? Something like that. It's called a drip irrigation system, where they would have the source of water coming from some type of pump or well, or some type of instrument that would hold water, like a vat or so forth, right? Anywhere else? If, let's say there's no farmers to plant, to water our crops, and the crops still survive all year round, where do the plants get the water from? Yes, Daisy.
Farmers, they usually plant their crops in the rainy season because some of them are far from rivers, and when they dig holes, wells, they are not able to reach up to the water, so they prefer to plant their crops in rainy season so that they cannot die, they can survive with the rainwater.
Okay, very good. So we would have plants surviving or getting watered, one, by some type of manual activity that a human would do, which would be putting a drip irrigation system, watering the plants themselves. We would get plants getting water from the rain. Is there any other way they can get water? Yes, Irma.
And by streams and lakes.
By streams and lakes. Explain how would that be by streams and lakes? Anybody wants to? Okay, let me give a scenario. Let's say there's no streams and lakes about, right? And it's not the rainy season, and this plant is surviving. Where is the plant getting water from to survive? Because the plant needs water as much as it needs sunlight. So it's not rainy season. Nobody's watering the plant. How is this plant still surviving? Yes, Daisy.
Some plants have some large roots, so they go deep into the soil for search for underwater.
For underwater, what's the correct term that we want to use?
Underground water.
groundwater, right? So it means that plants can access water, the plants that have deep roots can access water from groundwater. So we don't only use the rain, we don't only use a manual process, but we can also the plants can also access water from groundwater. Is that clear? Does that make sense? All right, good. And the last question is, how is groundwater different from surface water? Yes, Edwin.
Groundwater is different from surface water because surface water is water that runs on the surface. So, it has current on it. With that current, it carries all the dirt and And then groundwater is water that is infiltrated into the ground and then accumulates in such aquifers.
Aquifers underground.
They
Very
are
good.
They are there, and depending on a natural process, it can end up somewhere where it can be a spring or something where it can be released again.
So surface water does not necessarily go through the infiltration process as would the groundwater. Remember, we did an experiment with the different types of soil and the infiltration rate, right? So those waters that would infiltrate or soak through the soil would be called the groundwater, while surface water does not necessarily go through the infiltration process. Now, humans need water to survive. Can you survive off salt water without doing some kind of distilling or purification process? No, so human beings, we mostly need fresh water to survive, especially in the form of drinking water. Only 3% of the world's water is fresh water. Only 3%. So 97% of the water is more salt water or water that has a high level of salinity, right? And that would be in the form of oceans and seas and so forth. 2/3 of that 3% of the fresh water is frozen, forming polar ice caps, glaciers, and icebergs. And the remaining 1/3 is either surface water that we would find in rivers, creeks, and lakes, or groundwater. And where is groundwater found?
Underground.
Under the ground. Good, we're getting that. Now the water under the ground. When water flows over land, it does one of 4 things. One, it either evaporates, it's either taken up by plants, it runs off into creeks, rivers, lakes, or oceans, or it soaks into the ground. And only water that soaks into the ground through the process of infiltration. So notice here we have a pumping well, right? And here we have a stream. Notice the groundwater flow underneath. Notice the water table. And we have precipitation. So precipitation would come down in the form of rain. And then the water would soak into the soil using the process of infiltration. And that water will continue down and it will go to the water table and it will go to the groundwater floor. Now notice how deep they had to dig that well to access the water table, right? So that they can get water. And some of the water is also accessible through the stream. Now, a little bit earlier Edwin mentioned, and this just goes back to show our groundwater and the water table, that we would have the unsaturated zone, and then right below that we have the water table. And all of that water in the water table and in the saturated zone is called what? Is called groundwater. Now, in front of you there are 2 cups. And I need 1 volunteer from each group. So who's the volunteer? Stand up. Please. The volunteer from each table. One out of you 2 girls and one out of you. I just need to know who you are. Okay. Kyle, Ainsworth, Stephen. Okay, you can sit back down. Yadira, Christian. All right. So put the 2 cups in front of you. That was a unanimous vote against you. Put the 2 cups in front of you. And I need you to do a taste test. I need you to taste a little bit of each cup of water. No, don't swallow. A big gulp. Just taste the water and then you tell me the difference. Just a slight taste. Are we finished, Kyle and Ainsworth? Okay, now. All right, let's get back to focus. Now, I saw some of you take some of the water and was quite pleased, and then you tasted another cup and I saw some remarks on your faces. Now, why those remarks? I was not trying to poison you or anything like that, so I can't even imagine why you people would put your faces that way. What's wrong with the water? Kyle, what's wrong with your water?
Salt.
Both of them are salty? One is salty? Okay. What's wrong with yours, Ainsworth? One is salty, one is regular. Stephen, boy, you took a big gulp. I told you not to take a big gulp. I hope your pressure doesn't go up.
One salty and one, I don't know if you're fresh, but clean.
One is salty and one is not salty. Yadira? Evelyn, you did the taste test. What's wrong with your water?
One is salty and the other is fresh.
One is salty and one is fresh. Christia, what's wrong with your water?
It's the same water.
How many people enjoy drinking the salty water and think that it has the benefits? It tastes kind of nice, but can you live off the salty water? If that was the only type of water that was available, do you think you will be able to survive?
1 day.
1 day? Your body might adapt? Stephen? 1 day. So you wouldn't have to do any processes to that water. You'd be able to drink it just like that? No. The same way that human beings cannot survive off water, the salty water that has a high level of salinity, right? Remember, we use the term salinity. It is the same thing that goes for plants also. Salt water is more dense than fresh water, therefore it sinks. And when the water table elevation is too low, it causes salt water to flow into the freshwater aquifers. And that is the process that we call salt intrusion. So whenever there is a drought going on and we don't have enough rain or anything happening, there's not enough infiltration in the soil. And so the water table does not get a lot of water and the levels will go very low. And once the level is low, remember we said that salt is more dense, therefore it sinks. It means that the water in the water table will have a high level of salinity, which means that it will be very salty. Now let's watch a little animated video called Salt Intrusion.
Well, Mr. Aquitard, it appears you are suffering from a severe case of saltwater intrusion.
What's that?
It's something that happens when you waste water by sucking it out of the ground and not putting it back. Say, you haven't been wasting water, have you?
Who? Me? No way! Oh! Go, 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 go. Bleh.
Too bad. I'm afraid if you can't conserve water, we're going to have to put in an injection well or two.
Whoa, let's talk.
Now, you watched the salt intrusion video. Now, what did the doctor say was the cause of the salt intrusion? Yes, Erwin.
The patient was wasting the fresh water, so the salt water replaced the fresh water when the fresh water ran out.
Was wasting the fresh water. But more than wasting, he was using it up and not doing what? Yes, Kyle.
He was not put it in back.
He was using the fresh water and not replacing it. And if it isn't replaced, remember we said that the salt water sinks at the bottom because it is more dense. And if that is dense and we have little water down there, we will have a high level of salinity, which means that more water will be found in the water table. Right? Now let's look at this diagram. We have the land surface there and we have the water table. Now below the water table we have all of fresh water. Now if you notice about 2 slides ago when we noticed where the streams were, now all water that we will find in the water table is somewhere or somehow connected to one another, right? That we would have some from the infiltration process, and we would also have a connection to a surface type of water. And that surface water may be a river, it may be a stream, or it may be ocean. So there will always be one leading into the other. Now, if you can go back. Here, what we call a zone of dispersion, this is what separates the fresh water from the salt water. Now, when the water from the water table and the fresh water gets too low, meaning that the water would get seriously low here, we have a problem right here in the zone of dispersion, because we have salt water getting in, right? And let's say that we would have to pump a well. We would have to put in a well here. If the well is not getting enough fresh water from up here, it will seek water that is lower, right? And the water that is lower will be more, has a higher level of salinity, because salt water is dense and the salt would more sink at the bottom. And that is how saltwater intrusion occurs. And as we continue, we're going to learn what the importance of why we need to put back water into that water table. Salination. Human activities such as clearing land increases saltwater intrusion. Now, why clearing land would increase saltwater intrusion? Why on earth would that happen?
When you clear the land, you remove the trees, and then the roots will come out. Then the roots will not suck in the salt water, so more salt water will be underground. Underground.
That's a very good observation. We need to expound on that a little bit more, but you have the right idea. Anyone else before we move on? No? Let's move on then, and we're going to come back to what Erwin said, because that is very important. Water that drains through the soil and reaches the water table is known as recharge. Can you say that word? Recharge. Recharge. So whenever the infiltration process takes place and water goes into the ground, called groundwater, it is called recharge, like you're recharging a battery, right? And water leaving the groundwater through uptake by tree roots, or when it flows into a river system, is called discharge. So whenever the trees take up water, remember the types of trees that Daisy spoke about that has deep roots? Whenever those take up water, It is called discharge. And whenever the infiltration process occurs, it is called recharge, like you're recharging a battery, right? So then see what happens here. We have the water here, and we have the salt. The roots from the plants here is taking up water, right? Now when the water table has low salinity, means that it has less salt, it is easier for the plant to take up the fresh water and the salt water remains behind. What happens if I put a little bit of salt in water? Will it affect how it tastes? Yes. A little bit? Okay. What happens if I put more salt in there, like the salt water that you just tasted? It becomes more dense. Look at the colors. Look at the color difference. Does it look more cloudy? Does it look more cloudy? How many people agree that it looks more cloudy as opposed to the fresh water? Right? Okay. Now, that is because it contains more particles in there and it is more dense. Now, do you think it would be easier for the plant to take up water that has in more or less salt?
Less.
Why less, Ainsworth?
Less because the salt water is maybe because it's more dense than the fresh water.
Mm-hmm.
And I don't know.
Anybody else wants to help him out? It is just easier, it is much easier for water that has in less salt for the roots to take in the water. As opposed if the water was very thick and dense with salt, it would be difficult for it to extract the fresh water into its roots, right? So then we have the water, the plants taking up the water, and then the water is being released back into the air through the process of what? When we talk about the water cycle, through the process of transpiration. And we also have water being poured back into the soil, right? And it goes back through the process of infiltration. Good. Now, who can explain this process to me in your own words? The process of salination. Yes, Ainsworth.
The recharge is when the water from like infiltration is recharge is infiltration, and discharge is when tree roots suck in the water.
And that is called?
Discharge.
Discharge, very good. Anyone else? Yes, Edwin.
The process of salinization in groundwater occurs when too much water is being discharged from the water table and it isn't being replaced, but when it is recharged with salt water, there will be more salt water in the groundwater and it becomes saltier.
Okay, very good. Now, to see if you understand the processes that we just explained, we have a concluding activity, a project presentation, and you have newsprints in front of you that you're going to use to record your answers. And there are 2 questions there. What are some effects of salt intrusion in aquifers when there is too much salt in our fresh water? What are some of the effects of it? Right? So you have those, and you have exactly 5 minutes to answer them in your groups. You have 5 minutes to answer both questions. right, could your presenters kindly line up there so that we don't have a lot of movement when you're trying to get out of your seats? Line up there. Whoever is presenting. In 5, Evelyn or Yadira, quickly choose your presenter. 4, I'm not seeing anybody up there yet. 3, 2, to the side, Aiden, to the side. And as we call you up, then you'll just come. Let's give this group our undivided attention. Aiden, come to the front kindly, please.
The plants in the area will be affected and the water will not be drinkable to humans. We can make barriers between the salt and fresh water.
Okay, thank you very much. Give Aiden a round of applause. He said that the plants in the area can be affected and the water will not be drinkable by humans. And we can make barriers between the salt and the fresh water so that we don't get intrusion. Very good. Anna.
Effects can lead to dehydration. 2 can lead to death. For number 2, when using fresh water, you should replace what is being used to prevent saltwater intrusion.
Okay, give Anna's group a round of applause. Thank you very much. A weak applause, but an applause nonetheless. No, we'll try better next time. Leticia?
When salt water is consumed, it can cause that individual to get dehydrated. It can cause dry skin. Can use less fresh water.
And that is for how we can manage the intrusion. Okay, give her a round of applause. All right, a little bit overboard, but thank you.
Some effects of salt intrusion into aquifers are: it will affect plants and people will not be able to drink it. We can manage saltwater intrusion by not wasting fresh water.
Okay, give that group a round of applause. Evelyn?
People can get sick by drinking it. Example, diarrhea and dehydration. Affects the plants whenever they try to absorb it. The salt cuts off the flowing. We can manage it by stop cutting the trees. Also by not wasting too much water.
Okay, give that group a round of applause. Okay, girls, you can sit down. Thank you very much. Now, my last question is, one of the effects of salt intrusion into aquifers is sea level rise in the form of flooding. How would that happen? Think about it. How would salt intrusion affect or cause flooding? Yes, Erwin. Erwin?
So when the sea level rises, it goes on the surface, then it penetrates into the ground, then it joins the groundwater, turning the groundwater salty.
Okay, that's a good point. Anyone else? Can you think about how it would cause flooding? There's a process that would have to happen, but eventually it can happen. Yes, Edwin.
I think that when there's too much salt water underground, maybe eventually it will start overflowing or something because of the pressure of the sea or the ocean. Maybe
Okay.
pressure of it causes it to rise or something.
A part of that is true. To conclude our lesson, let me share why it would affect sea level rise. Notice we said that under salination, human activities such as clearing land increases saltwater intrusions, and irrigation is one of the main sources of salination. Now this is what happens. Deforestation. We remove the plants and we don't plant them back. Right? Now, what is the role of the plants? How do plants acquire water? Remember we spoke about the various ways they can acquire water, right? One through rain, one through maybe human activity like a drip irrigation system. And one of the main ways that these plants acquire water is taking it up through their roots. Now, if you clear the land, doesn't that affect one of the ways in which we get discharge? Ainsworth, what is discharge? When the roots take up the water. Now, what happens if there are no trees to take up the water? There are no trees to take up the water, but we still get precipitation. Water is still being infiltrated into the soil. So there's an imbalance. It rains, water is going into the soil, infiltration process occurs, but there is no way for the water to come back out of the soil. And one of the main ways for the water to come back out of the soil will be through discharge. We're having a lot of recharge where the water is going in, but there is no way for the water to come out. So what eventually happens?
There will be too much of a discharge, and then that will cause flooding.
And that will eventually cause flooding, right? And so that is one of the ways in which it can affect sea level rise, and one of the ways in which flooding can occur. Do you understand that process? Right? So I will leave you with that. Thank you very much for your participation. Give yourselves a round of applause.